Hi, and welcome to this section of the Differential Equations Tutor. In this section, we're going to solve a couple of problems that what I'm going to classify as elementary differential equations of second order or higher. You're not going to have too many test problems that are this easy, and I say easy because to understand what to do is easy, but just like anything else, you can make a ton of mistakes along the way. So I'm going to kind of shepherd you through that and show you how you would actually solve some of these simpler second order and higher equations. Later on in the course, we'll have more involved solution techniques to conquer different classes of equations. Second thing I want to tell you is that once we get to the answer, I'm going to make it a point to show you the particular solution and the homogeneous part of the solution, which we just talked about in the last section, because it's really important that you understand what that is, so it's not so nebulous to you. So let's solve the following differential equation. Let's say we have second derivative of x with respect to time is equal to sine of 2x, or 2t. Okay? And let's have an initial condition. X at pi is equal to 0, and x prime at pi is equal to 1. So the function that we get when we evaluate it at pi, we should get 0. The first derivative of the answer we get when we evaluate it at pi should be equal to 1. So this is a pretty simple looking differential equation. It doesn't go crazy off the board. The first thing you need to know or to look at, but when we get into a lot of solution techniques, it's going to kind of overwhelm you a little bit. And because there's a lot of different ways to attack a problem. My advice to you is when you first look at a problem, okay, the first thing you should look and say to yourself is, can I just integrate this equation to get the answer? Just like we did in Volume 1 of differential equations. We did some problems that were really easy. We could just sort of integrate to get the answer. Well, when we look at this, we have a second derivative by itself, and on the right-hand side, we have a pure function of time. So when you think about it, the first derivative, dx dt, is going to really be equal to the integral of this whole thing. So when we integrate this, we're going to get the first derivative. In other words, when you take the integral of the second derivative, you're going to get a first derivative. You integrate the right-hand side, you're just going to be integrating sine of 2t dt. So really what you're doing here is because you have only one derivative on one side, and because you have pure function of time on the other side, then you're allowed to integrate both sides of a differential equation. So integrating the left is going to give you a first derivative. Integrating the right, we have yet to do. When we get the answer, we're only going to know what the first derivative is equal to. We integrate it again to recover x of t. So it's kind of the thing you learned from Calculus 1. Integrals are opposites of derivatives. Here we have a second derivative. We know what it's equal to. So if we integrate 2 times, we're going to recover the original function with some constants of integration stuck at the end, which we're going to get rid of the constants with our initial conditions. We've been doing that in the other part of the course also. So the reason this is allowed, the reason that it's possible, is because we have one derivative on one side and we have a pure function of time on the other side. If you have more than one derivative over here, like maybe you have third derivative, second derivative, and a first derivative over here, you're not going to be able to just integrate that. And so I think we've shown through the last section and the section before that that in general the equations can get complicated enough where simple integration is not going to work. But always ask yourself as a first step, can I integrate? Okay. The next thing I want to say before we go any further, because what we're going to do next is integrate this, is notice that this is linear. We have a second derivative